Hey everyone, in this video we're going to talk about how to find the distance between 2 points on a graph. So first let's draw a graph, start with our y-axis. So we'll draw a line going up to down, and then we'll draw our x-axis from left to right. I think that should be enough. Let's go ahead and just write down our numbers on the x-axis. So 1, 2, 3, 4, 5, 6, 7. I think that's it. That goes to infinity. Let's write some negative numbers down. So -2, -3, -4, -5 to negative infinity. And let's go up. So 1, 2 on the y-axis, 3, 4. Let's go a little further up. So 5. And let's just do one more. Let's do 6. -1, -2, -3. I think that's good enough. Okay, so let's say we had 2 points. Let's say we had 1, 2. So 1, 2, how do we plot that? Well, 1, 2, the x-coordinate is 1. So 1 is right here on the x-axis, and the y-coordinate is 2. So you're going to go up 2 spaces, 1, 2, and there we go. That is 1, 2. Perfect. So that's 1, 2. Let me just rewrite it. 1, 2, and let's also write 3, 2. So how do we get there? So 1, 2, 3 on the x-axis. Good. And 2 up. So 1, 2 on the y-axis. There we go. That's 3, 2. And again, that's because we start at the origin. So 3, we move 3 spaces to the right. 1, 2, 3. And 2, we go up 2 spaces. 1, 2. And that's how we get to 3, 2. So we have these 2 points here. And let's say we wanted to find the distance between 1, 2 and 3, 2. So we want to find the length of this line, the distance between them. So in this case, it's fairly simple. As you can see right here, the only difference between them, between 1, 2 and 3, 2, is the x-coordinate. They have the same y-coordinate, 2 and 2, but they have different x-coordinates, 1 and 3. So all you have to do, you could simply just subtract them. So you could take the larger one first, so 3 minus, and then this other x-coordinate, 1. 3 minus 1 is 2. And that's it. The distance between them is 2. And the length of this line segment between these 2 points is simply 2. And that's how you find the distance between 2 points, but that only works if they're on this, or if they have the same y-coordinate. Let's talk about if they have the same x-coordinate. So let me erase this. So now we're just left with our first point, 1, 2. So let me just rewrite it, 1, 2. And let's say we had another point right here, 1, -2. So this is 1, -2. And again, you just start the origin, you go 1 to the right, and -2, you go 2 spots down. And that's how you get to 1, -2. And let's say we want to find the distance between these 2 points. So they have the same x-coordinate, 1 and 1. But check this out, they have different y-coordinates, 2 and -2. So all you have to do is subtract them. So let's subtract them, 2 minus -2. And what's 2 minus -2? What's a double negative? 2 minus a negative number? That's the same thing as 2 plus 2. So that is 2 plus 2. And that gives you 4. 2 plus 2 is 4. So the length of this line, the distance between these 2 points is simply 4. And that's it. So that's how you find the distance between 2 points that have the same y-coordinate and different or apologies, they have the same x coordinate but different y coordinates. So those are two examples of points that have the same either x coordinate or y coordinate. But let's say we had a different scenario. Let's say we had another point at 5, 6. So 5, so we go 1, 2, 3, 4, 5. And then we go up 6. 1, 2, 3, 4, 5, 6 up here. So this is 5, 6. 5 is the x coordinate and 6 is the y coordinate. And let's say we want to find the distance between these 2 points. So let me just move this down here, just so I could draw the line between them. So let's draw a straight line. Excellent. And we want to find the distance between 1, 2 and 5, 6. And it is this straight line right here. Now, it's not as easy as subtracting the x and y coordinates. We can't do that. That's the wrong way to go about it, and that won't give us the distance. We have to use a different method. So, you might not see it, but the Pythagorean Theorem is actually in this problem. It's hidden in here. And that is because there is a right triangle that you don't quite see, but if we draw a line down here and draw a line from here, so 1, 2 all the way to the right and 5, 6 all the way down, and where they meet, what is that point? What are those coordinates? So this is 1, 2, 3, 4, 5. So it has an x coordinate of 5, and it has a y coordinate on the y-axis. It's 2. So 5, 2. There we go. So we have a right triangle right here. So now, how does this help us solve our problem? Well, this distance right here, this looks a lot like a hypotenuse in a right triangle. So let's call it C. And the green sides right here look a lot like legs. So let's call this leg here A, and let's call this leg here B. So if we know A and B, we can find C, because according to the Pythagorean theorem, let me write it over here, A squared plus B squared equals C squared. So if we know A and B, we can find C. Good, so do we know A and B? Well, we can find out. We can find A because this is similar to one of the problems we were doing before. We are finding the distance between 5, 6 and 5, 2. So they both have the same x coordinates, 5 and 5, and they have different y coordinates, 6 and 2. So because they have the same x coordinates but different y coordinates, all we have to do is subtract their y coordinates. So 6 minus 2 equals 4. So the distance between 5, 6 and 5, 2 is 4. Therefore, this A, which is supposed to represent their distance, is simply 4. Let me just move this. Let's move it over here. And A is simply 4. Good, so we found A. And now let's find B. So what does B equal to? And again, let's take a look. B is the distance between this point, 1, 2, and this point, 5, 2. And take a look at both of these coordinates. They have the same y coordinate right here, so they both have the same y coordinate 2, but they have different y coordinates. This one has different x coordinates. This first point has an x coordinate of 1, and the second point has an x coordinate of 5. So because they have the same y coordinate but different x coordinates, to find the distance, all we have to do is subtract their x coordinates. So 5 minus 1, and that gives us 4. Good, so that is 4. So B is 4 and A is 4, and then we can go ahead and find C. So let's go back to this Pythagorean theorem right here. So we know A and B. As we said, a is 4, so 4 squared, plus, and b is also 4, 4 squared, equals c squared. So let's go ahead and evaluate this. So 4 squared is 16. So 4 squared is 16, plus 4 squared is also 16, equals c squared. And what's 16 plus 16? That is 32. So c squared equals 32. And c squared is 32. How do we get to c? So we can take the square root of both sides. That will keep the square root will cancel out the square. And c is just radical 32. So that's radical 32. And we could actually simplify this if we wanted, because radical 32 is radical 16 times 2, according to the product rule for radicals. And this comes out to radical 16 times radical 2. And radical 16 we know is 4, so let's scroll down a little bit. So 4 times radical 2. So a simplified way of writing c, it's simply 4 radical 2. 4 radical 2 is c. Therefore, the distance here, the c that we're looking for, this is 4 radical 2. That is the distance between 1 comma 2 and 5 comma 6. It's precisely 4 radical 2. So that's how you use the Pythagorean theorem to find the distance between any 2 points. And now let's talk about the distance formula. So the distance formula is derived from the Pythagorean theorem. Let's say we had any 2 points. Let's mark them down here. And let's call this, although we can see what it is, this is 2 comma negative 4. Let's write a more general formula so you can see where the distance formula comes from. So let's just call this x1, y1. And let's call this point over here x2, and let's just make it a different color. Let's call this point over here x2, comma y2. And we wanted to find the distance between these 2 points. So how exactly do we do that? Well, there's a distance formula we can use. But first, let's do the same thing that we did in the problem above, in the first quadrant up here, by forming a right triangle and seeing how we can derive the distance formula ourselves. So let's scroll down, and let's go ahead and form our right triangle. So let's make the legs of this triangle. So let's put this down here. Let's draw a line from here to here, and let's draw a line from here to here. And that forms our right triangle, where the orange is our hypotenuse, which we'll call C. So we're trying to find C, which is the distance between point 1 and point 2. Point 1 being x1, comma y1, and point 2 being x2, comma x, or x2, comma y2. So let's go ahead and apply the Pythagorean theorem. So it is a squared plus b squared equals c squared. In orange, c squared. Scroll down a little bit. And what is a exactly? So let's call this, let's make that in blue. Let's call this leg A, and let's call this leg B. Let me just move this down a little bit so it doesn't get confusing. Just move this down as well. There we go. So we have our legs A and B. What is A exactly? So A is actually just x2 minus x1. It's the difference between these two x coordinates right here. So let me mark them. It's x2 minus x1. So it's the difference between these two x coordinates. And then b is actually the difference between these two y coordinates. So b is actually just y2 minus y1. Good, so a is x2 minus x1. it's the difference between the x-coordinates, and b is y2 minus y1. And similar to the problems we did in the beginning of the video, you can imagine a point right here. And this point right here, it has coordinates. Let's just move this over here. But this orange point right here, it has coordinates. It has the same x-coordinate as this green part. So it has the same x-coordinate as the green, x2. And it has the same y-coordinate as this blue point. So y1. So that's where this is. So what's the distance between the blue point and the orange point? The distance between the blue point and the orange point is x2 minus x1, which is a. So a is x2 minus x1. And similarly, what's the distance between the orange point and the green point? Well, they have the same x-coordinates, they have different y-coordinates. So the distance is y2 minus y1, which is our b. So we found a and b, so we can go ahead and plug it in the Pythagorean theorem right here. So let's go ahead and substitute it. A is x2 minus x1, and we're substituting it for a, so let's just make it red. Let's go ahead and make that red. So a is x2 minus x1, and then don't forget to square it, the entire thing, plus, and what is b? So b is y2 minus y1, and square the entire thing, equals c squared, which is what we're trying to find. So all we have to do to find c, we have c squared, we'll just take the radical of both sides. So the square root of both sides. So that cancels out the radical in the square. So c equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is the distance formula right here. And that is how we derive it. So this is the distance formula. And it comes from the Pythagorean theorem. So for any ordered pair, if you had an ordered pair of x1, y1 and x2, y2, you can use this distance formula right here and plug in these coordinates, x1, y1 and x2, y2, so that you can find the distance between these 2 points. And that works for any points. So that's how the distance formula works, and I really hope this video helps. Please let me know down in the comments below if you have any questions, and thank you for watching.